Well, greetings, and thank you, David, for the introduction and for the chance of sharing the results of my work as part of a project at the department this year. This is an exciting project that I was invited to contribute to in the form of a chapter in an upcoming volume of the publication Muqarnas. I had not spent so much time going up and down the stack since my dissertation years, but the chases and the newfounds have been well worth it. The subject of my forthcoming chapter and this excerpt presentation is the Arabic and Persian traditions of practical geometry, which, as rich and extensive as they are, as two parallel traditions covering a long period and vast area, can still be thought of as a footnote to a single work. This is the Book of Geometrical Constructions of Abul Wafa Buzjani, composed in Arabic in the late 4th or 10th century, during its last decade to be exact, as I have narrowed down the years through a recent find, and a work that is amongst the earliest to deserve close attention. The centrality of this work to both early science and craft is not only because of the unique content of the text itself. For example, the rare and clear distinction the author makes between the geometrical constructions of the craftsmen and the geometrical demonstrations of geometers and their respective errors, quote unquote. It is also highlighted here for the range of questions and indeed misrepresentations that both the text and its tradition have generated almost every time they are given any attention, and the needed error corrections in the spirit of Buzjani himself. These include the work's various versions, translations, commentaries, and dependent compositions, often treated as one and the same work and from the same time and place. I have selected for magnification here subjects represented by these four icons. The who's of the story, in this case, the authors and patrons, starting with the main text on the top left, the what's in the case of compositions and transmissions, a revealing translation on the top right, the how's in the case of traditions and their relations, a non-textual representation here on the lower left, and the why's in the case of distinctions such as constructions and demonstrations of the science itself, and why such subjects are important. This is in the contextual representation on the lower right that I will discuss last. All from the standpoint of history, not science or art, as we were just discussing. My presentation has four parts, some with multimedia components. In the first part, I use an electronic project I have called Micro-Mapping Early Science, here's on the left, to track the footpaths of Buzjani's Book of Geometrical Constructions as part of a largely understudied tradition. I will use some features of that project that take the tradition from Baghdad, where this and other relevant works were supposedly written, to various cities within Arab, Persian, and European lands that have any relevance to that tradition or the text. The second part of the presentation is what forms the core of my own work, starting with a new dating of this work through a coin represented on the top right, as distinct from the work of others, and what must be noted or corrected in primary and secondary sources. The third part highlights key concepts such as constructions and demonstrations in geometry on the lower left, with reference to related fields, some drawings from an evolving index of terms as a key component of my study. And the last part is meant to capture a context for some relevant scientific traditions, ending in a short film called A Quartet of Scientific Traditions, circa 1000 CE and beyond. The film features the main sources, parallel paths, and different faiths of four related traditions in both Islamic and European lands, starting with geometry and the Book of Geometrical Constructions. So I hope that these are sort of short enough, and I go through them as we proceed. To begin with the first part and the footpaths of that work, the map used here are part of the micro-mapping early science project. The base maps on top are taken from the Tübinger Atlas at Pusey Archives and supplied with interactive and color-coded features, initially in collaboration with Harvard's Academic Technology Group and faculty aid programs. They are used not just for zooming or sorting purposes or avoiding blanket labels with their own values, but for identifying specific paths and especially overlaps difficult to conceive without such technologies. For example, on a map representing the year 1000 and a place such as Baghdad, we can see, besides the historical map of the region at the time of the Abbasids and local dynasties, timelines with links for authors and works, including encounters through overlaps otherwise difficult to conceive, like the simultaneous observation of a lunar eclipse by Bozjani and Biruni from two different cities at a particular date. This one, link you can, search through my own work, but I just wanted to show you how it works. We can just go to a year such as 1000. I mean, that's the only one that is populated right now, and a place like Baghdad. And again, it's not just for the visual aid that this gives us, but and the links that we have to different scholars. Now we have 4 that I will be talking in the film, but also the overlaps that these may have that would not be immediately there unless a work reports it. Okay, now the next slides okay, we were kicked out of the PowerPoint, I guess. Here's where we are. Okay, the next slide follows the trail of the first of the 4 authors and works featured on the map menu and in the film, namely Bozjani's Book of Construction and its tradition as a template for the others. The first line on this map starts from the birthplace of the author, Bozjan Khorasan, marked in green for Persian lands, and his move to Baghdad, marked in red, for Arab lands where he lived until his death, according to his early biographers. We can confirm that he spent most of his life in Baghdad from contemporary reports of his observations in Baghdad at the top 2 instances, according to Abu Rayhan Biruni, and then pre-arranged joint observation with Biruni himself in Kharazm of the lunar eclipse of the year 337/997. But what about the patrons and forces behind such activity? Of the Buyids who are repeatedly associated with the cultivation of the sciences, crafts, and literature of the time, there were successive patrons directly linked to Bozjani's scientific works, with reigns extending from Baghdad to Persian lands. The earliest of these patrons is associated with his first observations in Baghdad, another with his dedication of a similar practical manual, the Book of Arithmetic Stations in its short forms, another with his observations at the Royal Gardens, and most important for this discussion, the patron named in his book of geometric constructions for ordering the book. Bozjani's direct association with the Buyid regent of Isfahan seems to be a misreading for the titles of the same patron, whose correct identity would be important for detecting trends versus isolated cases. If I start naming all these people, the whole lecture will be names and dates. So I'll just let you sort of get a snapshot of it. Now, a closer look. We have this one. A closer look at the many lives of the work with the title, full title is What is Needed by Craftsmen from Geometrical Construction, that's the translation usually given. This work is the only one of its kind from any early period. It is not a translation from an ancient work, but an original Arabic composition, and among the first to generate a rich and long Arabic and Persian tradition, some now in Europe. First, the Arabic tradition. So we have here on this slide the original compositions, known transcriptions, current locations, and any publications or versions associated with the text. For a sense of the geography and chronology of this work, and the scope of much needed study, I sort of collapsed a lot of slides into these two, just to show you the parallel slides would give you some in dotted form for intermediary positions that they may have held the path of these traditions. So here's the Arabic tradition. The earliest known copies are in Cairo. We don't know where they may have been before. Then one through Samarkand to Istanbul. Then two that are defective but still overlaps, major overlaps with Bozjani's text in Milan and Uppsala. And then for the compositions, we have an early one by Bozjani himself and another one by Kamaluddin ibn Yunus, who wrote a commentary on this text several centuries later. And that one has a very interesting history itself, because it was dedicated, dedicated. First of all, his name is Mosali, and he studied in Baghdad, so we don't know where he wrote that work. But then he dedicated to Salah ad-Din, and the transcription is dated in this case. So it says that it's in Maragha, and it gives the year 6 AD, corresponding to 1282. And then on the title page, we have something to the nature that it was transferred from Isfahan to Mashhad, where these both these unique manuscripts sit, the two related compositions. The Persian translation is much more extensive and condensed, but much less known. Of the supposed earlier translation, there is a manuscript in Tehran, based on which an edition has been made without reference to a second one, which we have in Mashhad. But then the most important and interesting one is a later Persian translation, and I will be talking about that a little more, which is bound together with this anonymous Persian text that a lot of people are excited about, and is kept in Paris. So that's sort of the general picture of it. Okay, now I get to the part of my presentation about the telling lines of a few of these Arabic and Persian sources, starting with the line of texts. Now, here's a selection of 4 texts from the Arabic and Persian traditions, which I've collected so far to piece together the textual traditions. I mean, this is not a complete list. All but the first items in each case are known through a unique, meaning single manuscript. And I will here focus on the first couple in each case, if I have time, all 4 of them, if not just 2 of them. And what can they tell us that we did not know before, including errors of previous publications, some with very basic factual problems. Bozjani's geometrical constructions in Arabic is the only one of the texts mentioned that exists in a published form as a primary source. This facsimile reproduction of the Istanbul manuscript published in Tehran in 1992 cites it as a unique copy without mention of any other manuscripts or a previous critical edition in the same way that that edition, published in Baghdad in 1979, is based on only a partial list. The two manuscripts in Cairo and this one in Istanbul. Without citing the versions in Milan and Uppsala, which has its own problem because it's attributed to Farabi apparently wrongly. But the folios here already tell us something beyond the author's full name, text title, and the manuscript's date and place through the stamp of Ulugbek's treasury on the right. Looking closely at the opening lines is enough to decipher a clue to what is a largely overlooked sequence of information. To my knowledge, the only person using the few titles of the patron in the very first lines to estimate the composition date of this text is the author of the article Abul Wafa Latinus, cited on this slide below, and lender of this great color scan. I only have a black and white, and the facsimile, of course, is here. But just recently, I found a coin in the catalog of the British Museum for a more firm dating. It has the same exact titles for Baha'u'llah as in the dedication. Below the words Madinat al-Salam for Baghdad and the year 381 equal to 991 or 2, placing the composition date between that and Bozjani's death around 388/998, which is a more documented form of dating than the one below it based on assumption of certain titles at certain dates, which is still a very innovative way of finding the date. Now, for the related geometric composition of Bozjani, which I mentioned, the dedication has been read as Mu'ayyid al-Dawla, the uncle of Baha'u'llah, regent of Isfahan at the time. But this seems a misreading for Baha'u'llah himself, as a parallel check of these sequences would tell you. There is a Mu'ayyid here that has sort of either thrown everything off or that the Mansur shouldn't be there, or the rest of them are just copied by mistake. But in any case, it sounds like it should be the same one, commissioned maybe by the same person. Now this may seem trivial, but naming the same person, even without the main mention of his order, adds weight to a more systematic support of such works, in addition to the case of a practical arithmetic dedicated to the patron's father. Now, we do have the case of the early Persian translation. I don't want to say too much about this because I want to concentrate on the later one. But there are problems with this. First of all, the one on the right in Mashhad, almost nobody refers to it. And when the recent edition of this text came out a few years ago, it's only based on this one and reconstructs the text based on the later one, which is very curious. I don't know why that happens. But much more can be said about that later Persian translation. On the left here is the unique and signed copy of that translation next to Bozjani's as part of an important collection that I mentioned and now kept in Paris. Note the close script of this text to the other one and the figure to this datable manuscript now in Istanbul, which needs a further sort of specialized eye to say if they're the same. I mean, I have my own hypothesis, but that's different. I've marked some factual informations below this page. For example, the equating the authors of this Persian translation and the anonymous text in Paris. Now, I mentioned that some of you don't know what this is, but people who work especially on geometry and architecture are very excited about that because of all these models that really don't have that much text to tell us. There's a lot of question marks about it. But in this case, for example, this modern Persian translation of these two texts for purpose of I don't know what, under the name of Iranian geometry, which whatever that means, is sort of assuming that these were written by the same text. I just wanted to mention this because there are a lot of puzzles that could really illuminate this textual tradition. Here I limit myself to the problematic readings of a single passage that I first show in that translation, affecting questions on the whole volume and its history, as well as early science and craft at large. On the closing lines on the right, for those of you who read Persian, by the person who completed that translation according to his own testimony and transcribed the whole codex on the basis of scripts alone, we have this transcription of his own name that ends with Kubanani Yazdi. Kubanan is a place between Yazd and Kerman. He also names those involved in any way, a contemporary father and son, whose names are fully given. And among various lines of text here, there are some lines of verse that those of you who know Persian poetry or any poetry know that it requires a different kind of attention, as all verses do, if only for the sake of misleading rhymes. Here Kubanani cites some verses in the context of praising the son for pressing him to complete the unfinished work of his father, deceased at a young age, with words for which the stakes of misreadings are too high in this case. To mention only the closing verse at the end, and an unpublished translation, the expression karkhane qaza va qadar, that is workings of fate and destiny, that is life, is translated as a workshop. The word khesht, meaning clay in context, is considered next to it as a mention of brick and a workshop. The combination Ostad Mohandes, meaning a master geometer, is translated as a mathematician, master craftsman. And karhay zamin, the works of this earth or this world, as simply geometry. I mean, just one example of many sort of readings into something which isn't there and really makes a big difference how we're going to assume if there were workshops at this early period. And we can't even date this, even though I'm getting close to that. Other problematic cases are the word for brother, often known as companion in both Arabic and Persian, as the actual brother of the author, which cannot be ruled out, and the confusion of a much earlier author, marked here with this composition, who's only mentioned for a commentary he had written a few centuries earlier. To close this section, here's a snapshot of my own findings on this author, whose writings, and especially the dates and places of his various works, most in his own hands, is much more important historically than scientifically. I'm waiting for the single manuscript of his letters from a private library, but based on this manuscript of his autographed works, which I just received, it can be documented that he was active in the 8/1400s in at least 3 areas within Persian lands, in the 1440s and 50s in Sari in the north, in 1450s and 60s in Kerman and Jorun, now called Hormuz, towards the south, and in 1480s again in Sari. My estimate of where the translation and transcription of the volume, if he did it, could be is in the middle range in both time and place. Bound in the Paris volume, which seems later than that autographed volume, as through my own work so far. There is also in that volume a historical map where next to Sari, Kerman, and Hormuz, as you can see, there is a larger mark and script for Isfahan with an illustration for the direction of Mecca from it. We know a European traveler and once owner of the Paris Codex passed through Isfahan in the mid-17th century. We also know that the mathematician Qushti, a contemporary of Kubanani, was in Kerman as well as Istanbul, where another owner of it is reported from. But none of these provide enough evidence to lead to any firm conclusions. This brings us to Isfahan in another context, this time regarding lines of craft and lines of proof, their possible relation, and how correspondences, however close, are not enough to establish actual historical relations in the absence of conclusive evidence. In the case of physical sources, which have their own telling lines, there are usually two cases. They either correspond to specific textual sources or they do not. I'll start with those without known direct correspondence with reference to a colored tiling here on the left here, which is from Masjid Jame Isfahan, also known as the Friday Mosque, a complex of structures, some dating as far back as the reign of the Buyids. I'm not going to make any hypothetical conclusions here, and I've sort of reduced my slides of this section to this single one. I had several that I thought is enough just to take a look at this one. And I have supplements if needed, or if you're interested in any part of it, I have it on a separate PowerPoint. The first three images, 1, 2, 3 here, with blue tilings are from photographs taken from my own camera. And the last one is from a recent publication, that one on the right, by a colleague. The first photo on the top left may be more familiar through some older publications, variously deciphering the name of the craftsman in the geometrical center tile to the right, and in the one case, to the corner verses. Let's see if I have a... Here, starting with Amal, and then Ibn Muhammad. And it's readable, even though it has been tried a few times, and it's not very important because we don't have any connection to that name. But here also, on the wall near it, we see the Ibn Muhammad. Some reading, if the few readings of this that have been done, they don't have Ibn Muhammad, but it's right there, and it continues. And I don't want to sort of confuse you with too many slides, but that's what it is. The correct name of this craftsman, not as critical in this case, can also be read on the cursive scripts on a nearby wall as Ibn Muhammad, this time with no reference to it or to him, but it specifies him as a resident of Isfahan, as Ahali Isfahan, that is in the rest of this writing on the wall. The correspondence of the same name on these physical sources does not mean a correspondence between them and textual sources. An example of the much less common case of physical sources with some textual correspondence is the image on the lower right from a recent publication where the patterns in other tilings in the same mosque, this time dated to about 473/1080, and their textual reconstructions are superimposed. This 2008 publication by Jan Hogendijk has follow-ups with forthcoming publications. And there are earlier published and unpublished works by authors, some associated with this department and some here, all to be fully documented in the chapter. Some of these are related to correspondences to the anonymous Paris manuscript in particular. But in all such cases, the best that can be done is to show a correspondence or assumed verbal transmission, not an evidence for an actual relation. The mere similarity between physical and geometrical constructions is no evidence for a historical relation, as is the case for either craftsmen using textual constructions or textual constructions being based on physical models. But there is at least one exception. This is a discussion by Bozjani where the methods of geometers and a craftsman are described as distinct methods of construction and demonstration. Here speaking as an eyewitness in a setting where both groups present methods, giving occasion to Bozjani to point out to the errors of construction in favor of geometrical demonstrations for being more accurate and significantly applicable to more cases, so that it's not just the case of four-sided figures. Now, without getting to the details of this discussion, Bozjani explains two methods by craftsmen, the ones on top, and one by geometers, just to get an idea of what he's talking about, which I've redrawn based on the manuscript, pointing to the errors of the craftsmen in the first two cases on top, and the validity and generality of the one by the geometers at the bottom, despite their closeness in perception, which he specifically mentions. He refers to their errors, to use his own words, aqlat, in a setting, majlis, involving both groups, geometers having little practice in constructing amal, and craftsmen lacking knowledge of proofs, burhan, with figures representing each method redrawn here. I'll just do a very quick overview of these two methods for you. In the case of the craftsman, one craftsman specified, translated here as an artisan, of the three equal squares, equal in area to a single square, which is the problem posed. One is a single square, I've marked it 1. Another is cut into two equal halves, marked 2. And the third cut into an equal-sided triangle plus 2 trapezoids, here marked 3 and 4. Once placed within a single larger square, the sum of these appears to be equal in area to that of the larger square. But he says in reality they are not, as the size of the square of the large one is more than that of the sum of the 3. And he gives the specific numbers that we don't have to worry about here. Here's the color version of it. You have these 3, and that's how you cut it. It's like application of areas, and I'll give you a couple of examples from geometry, which are very simple. So that's the incorrect method. The division of the squares by the correct method is described as follows. Very close. Of the 3 equal squares, 1 is the single square, again marked 1. 1 is cut into 2 equal halves, marked 2. And the third, this time, cut into 2 equal halves again. They are then rearranged inside the larger square such that the central small square is still inside. This time, the half squares are arranged around it in a way encircled by the triangle's longest sides or hypotenuse, as in this case, because those extra parts are equal. He proves that they're equal. So just you get a visual sense of what he's talking about. Again, through colors, that's how they would be. Now, such methods are clearly in the tradition of specific propositions with Euclid's element of geometry. This is one of the propositions from Book 2, Proposition 4, where the sum of the larger square, it's very, very simple when you think about it. The square, the larger square, this is equal to the sum of the smaller squares on the two sides. I think it's better to see it in color. So the whole thing is equal to the ones on the side and then the two rectangles. So it makes it sort of corresponds to an algebraic identity, which is why it's sometimes called geometric algebra. Again, a very problematic term. Here too, there is a correspondence, not always evidence, though I've come across one earlier than Bozjani, for the historical identifications of the methods of geometry and those of algebra, which is algebra is usually known not through symbols and functions in its historical meaning, but to find an unknown based on a known quantity. So in these cases, it's easy to extract from some measurements or some known quantities an unknown one. To sort of go back to the larger context, this may interest you. We do find evidence of the integration of Bozjani's text into the Paris collection through this one folio interspersed among the text, which I don't know whether it's misplaced or actually supposed to be there. This image and the wording on one of the folios is directly related to Bozjani's discussion, indicating that his text was used or his discussion was used in that very interesting volume. There is a marginal note below the figure about placing three squares, literally equal-sided rectangles. They don't really, the word for square, murabba, didn't really mean a square in the older text. You always specify that it's equal sides, because it could be a mustatil or it could be some other quadrangle figure. There are two ways for this to do. Again, not all three methods are given. I didn't give you the method of the one on the right because it was a little harder to see visually, but this one and supposedly the other one are meant here. The terms are standard forms for referring to figures of a proposition. These words are illustration, mithal, or surah, many times are used for geometrical propositions. The word for proposition itself is shakl, meaning form or surah. So that's what it is. Initially, proofs were just, here it is. So you can see there is no sort of actual. The last couple of sentences on the other side of the same folio, there is a surveying problem. If you sort of look at it from the other side, saving paper, they wrote a surveying problem on the determination of the height of objects through a plane mirror, to mention just the most immediate example. There are many examples of other text, optics, mechanics, surveying within this codex. The historical interdisciplinary nature of such subjects is clear from the collection of other works, including the inclusion of the same problem in an optical corpus and the overlap of the solutions with proportional relations used from mechanics to algebra, in this case calculating the height, AB, based on measurable distances through proportional relations, which I won't get into. But sometimes we do it in class. Sometimes we've actually reproduced this very simple surveying problem with a mirror, and then you can just measure. Somebody can be the height of the object, and it's very easily shown that that's how they try to calculate these measurements. Especially if something is very far away, you want to be able to sort of estimate its height. I think I'll just stop here and show you this short film to capture on a different note some of those disciplines that I mentioned and their similar starts and different ends in both Islamic and European lands, starting with geometry and the Book of Constructions of Bozjani and ending with the case of optics, which is next in line for similar treatments with the same few collaborators in the credit lines, including the co-producer and narrator of this film. This and a few other films in long and short versions are also part of an ongoing multimedia timeline for the interest of broader audiences as well. And I will take questions after this film, if that's okay.
هر کجا که آرامگاه مردمان بود به چهار سوی جهان از کران تا کران این زمین را ببخشیدند و 7 بخش کردند.
That the world was once defined in terms of its 4 corners and 7 quarters may be well known. Much less known is a time and place, reaching back as long as 1,000 years ago and as far as ancient Mesopotamia and Persia, and a quartet of scientific traditions in the days of 7 heavens, which came to hold a special place in that world beyond their own time and place. The quartet of geometry, astronomy, mechanics, and optics had a rich and long life in the lands of the Islamic Middle Ages, one that was both richer than other foursomes of the ancient and medieval worlds, and more long-lasting than the Islamic and European Middle Ages put together. Geometry and astronomy, 2 prime players in the quartet of early science, were a rich pair in ancient and medieval curriculums, not just keys to the so-called middle books studied between them. Mechanics and optics were at center stage for other reasons. Outstanding intermediaries, mixed mathematical, physical sciences, twin stars with parallel roots, similar starts yet different ends. Mechanics was a science of devices, focused on machines and productions, not just motion, with an impact more internal than external. Optics was a study of vision and experimentation, focused on sight more than light, and an impact on external European leaps more than internal native shifts. Some expressions, carried by all 4 fields over the centuries, reveal their historical associations. Geometry and astronomy, the respective gate to and queen of the sciences since ancient times, made their marks mainly through demonstrations and observations. Mechanics and optics later known as the most noble art and perfect science, were in turn subdivisions of geometry, which became the main grounds for the growth of scientific instrumentation and experimentation. But what was the world like around the year 1000 of the so-called Common Era, itself matched with different years in the lunar and solar calendars of Arab and Persian lands?
A period piece for timekeeping with the fitting face of a moon or sunburst may turn the dial to specific times and places. In Baghdad of around the year 1000, where the early growth of sciences coincided with court patronage, science was in full bloom in the land of 1001 nights. At the center was the Abbasid Caliphate, where early Arabic translations made from Greek, Persian, Sanskrit, and Syriac were followed by original Arabic compositions as early as the 2nd and 3rd centuries of Islamic rule. But it was also in the periphery of the aptly named Round City, as Baghdad was called at the time, that both theoretical and practical sciences excelled around the year 1000, especially in cities under Persian rule, from Isfahan to Khwarazm and from Hamadan to Abadan. In the capital city Baghdad, Persian scholars such as Abul Baqa Bozjani worked next to Arabs and non-Arabs under the patronage of Persian rulers like the Umayyad dynasty, while traveling to cities like Isfahan for other commissions. Bozjani worked on geometry among other subjects and produced a unique book of constructions on practical geometry in Arabic, the standard language of science at the time, with a few late versions in Persian, all surviving in single manuscripts. To the east, Abu Rayhan of Biruni worked under local Persian patrons on and beyond astronomy and astrology, and arranged a joint observation of the lunar eclipse in Khwarazm with Bozjani in Baghdad to find the local time difference in their respective cities. And a female courtier named Rayhane became a mysterious patron to his bilingual book of instructions, a work atypically composed in both Arabic and Persian, with over 500 questions and answers on subjects from geometry to astronomy and geography to astrology. To the south and west of Baghdad, there were other developments. A book of mechanics attributed to Abu Ali Sina, the Arabic Ibn Sina, and Latin Avicenna, is among many works associated with that well-known traveler, with a published autobiography finished by his student, recording his footsteps from Bukhara towards Gorgan and later from Hamadan to Isfahan. The Persian mechanical work Me'yarul Uqul may not be by Abu Ali Sina, but a similar book later gifted in Isfahan to the French tutor of a Safavid prince, credited with a bilingual French-Persian version, adds weight to the linking of a name as weighty as Ibn Sina with it. That the mechanical tradition was alive at this time is further supported by various sources of the period itself. Mechanical devices from levers, pulleys, weights, and balances to self-moving automata found expression in various forms, including texts and images of rarely checked literary sources. Among the earliest is the Persian Book of Kings by Ferdowsi, composed close enough to the year 1000, where war instruments combined with the science of stars in verses and statues of figures and horses filled with flammable mixes mirrored the past's improvised explosive devices. But the active period of science around this time stretches much beyond the east of Persia. Most importantly, a book of optics written by contemporary scholar Elaheh is linked to places to the far west of Persia, from Basra to Cairo, and to an Arabic tradition beyond European Middle Ages, all the way to the early modern period followed by the scientific revolution. The 7-volume optics was uniquely transmitted through both Latin and Italian versions and a printed edition, and more widely in Europe than Islamic lands itself, to a point where the author, known in the West as Al-Hazen or Al-Hassan, after his first name Al-Hassan, is portrayed next to Galileo a few centuries later. An exception was an important commentary a few centuries earlier by Kamaluddin Farsi, a Persian scholar with a name literally meaning from Fars, Persia, who was the main source for the diffusion of the multi-volume optics in his native lands. With the move of the temporal hand of that quartet from the year 1000 to a year such as 1300, and their spatial hand from the east clockwise to the north, there arose institutions such as the Maragha and Samarkand observatories, founded respectively by Mongol and Timuri rulers as centers of collaboration and transmission to both east and west. As late as about 500 years after the year 1000, a scholar from northwest of Persia could report that European scholars had sent mirrors to scholars in Khorasan, in northeast Persia, for experiment and testing, challenging the idea of a so-called decline at a time when Europe was rising to the more familiar peak of a scientific revolution in the 17th century.
And so it was that this and the other sciences in the foursome of geometry, astronomy, mechanics, and optics mark their own times and places to become key players in the quartet of world science.
Thank you for your attention. I know that we're later than we want to be, so I'll take any questions.